Meeting is being recorded.
Okay, welcome everyone to this week's OMR Architecture Meeting. So this week we have a fairly full agenda. For the first, I think, 2/3 of the time, we'll be giving sort of an overview of some of the work that's ongoing right now in OMR and where and work that is expected to land over the next several months out to a year time frame. Things that align with the goals of the project. And then for the last 30 minutes, Jack Key from the University of Alberta will be giving a talk on a project that he's been working on and perhaps a demo as well. So I'll get right into project directions. So before we start talking about where we're going over the next few months, I thought we could talk a little bit about some of the things that were accomplished over the last year in terms of code that was contributed or changes to the project itself or other things like that. These are only highlights. There actually was a lot more that was done, and I apologize if I missed something significant that should have been called here. But feel free to call me out on that if I missed something. From a project perspective, perhaps the most significant thing that happened is we actually did our first release, sort of a line in the sand release back in October. For that, we declared functional stability on 8 of the components that we have, and API stability on 3 others. There certainly is more work to be done there, and we'll talk about that in just a few minutes. We also welcomed 2 new committers to the project based on some great contributions over the past months on them. And this call itself actually broadened to more than just the compiler architecture, where we now talk about any aspects of the OMR project architecture. From a development point of view, in terms of code that's being landed in the code base, we did welcome a brand new backend into the fold. So a language agnostic ARC64 backend was committed earlier on this year. It was sort of committed piecemeal over time. But nonetheless, there's something there that that does run, and it's being used as it's being consumed in the OpenJ9 project now to deliver ARC64 support there. JIT-Builder, we did the work to get JIT-Builder to run and build on ZOS, and as part of that, Philip introduced the XP linkage for ZOS there. So that's a significant piece of work. And looking at development in totality, as of a few days ago, we had well over 800 PRs that were merged. And perhaps some of the more significant things there is that 44 of those were beginner issues, and many of those were actually taken on by sort of the non-regulars in the project, people that are looking to get up to speed on various aspects of OMR. And a number of those PRs as well were related to technical debt reduction, which is sort of one of the things that we need to continue to do over time. Testing improved as well. As a result of the ARC64 backend being introduced, a number of Trill unit tests were actually rewritten in Trill, and they replaced the compiler test ones. And the parser itself in Trill was rewritten recently to C++ to eliminate our flex and Bison dependence and to make it more portable into other projects. So, for example, into OpenJ9. From an infrastructure point of view, we moved to a new project website that we are still in the process of populating and getting more information there. But nonetheless, there is something new that we can build on. And we also did some work to move the Jenkins CI pipelines into the repo themselves, so that they're more visible, and others, and also so that more people can make changes to them as necessary. So looking ahead in terms of things that are coming, so these are things that are being done that are aligning with the goals of the project, meaning to provide a language-agnostic toolkit of components that can be integrated into other language runtimes. One of the things that we did last year, as I mentioned, was our first 0.1.0 release. We just consider that to be a starting point. We want to start doing more regular releases, perhaps on a 6-month cadence, but that's just an arbitrary thing at the moment. We do need to go through the process of figuring out what the process is going to be and how to define content for those releases and that sort of thing. But you know, having a release is an exciting step forward, and we just need to continue to build on that. I mentioned that only 3 of the 12 components, or sorry, 11 components, actually had API stability. We need to think about how we want to introduce API stability to the other components as well. I'm not saying that in the next few months this is we're going to have that stability, but I think that the mindset should be to start thinking about how we can increase that, and because the stability of the API is something that may hinder the adoption of various components in other language environments as well. And an aspirational goal, as always, is to reduce the backlog of issues and pull requests. I mean, as of today, we have maybe 102 pull requests on the backlog, and I think there's well over 600 issues that are open at this point. So we do want to spend some time going through and reducing that and making sure that the contributions that people are making or the requests that people are making are getting some consideration, and some of those changes potentially landing in the code base. So this is actually something that we're hoping that anybody that's contributing to this project can certainly help with. It doesn't have to be committers or the project leadership that have to do this. In terms of the components within OMR, the compiler component saw a fair bit of activity over the past year, and going forward, there's a number of things that we're looking forward to happening in the coming months. So the first is to deliver a RISC-V backend. So this was there was a contribution several months ago that has been under review. I think that it's getting very close to being contributed, and which will be a great step forward for the project. Yes. Sorry. Yes. Yes. I said contributed twice. Yes. I meant merged. Yes. If anybody's watching the general Slack channel yesterday, Jan mentioned that they were able to get a Smalltalk VM integrated with JIT Builder running on a RISC-V backend, so that's a fairly significant step forward as well. So the next real piece here is to get the actual backend landed into the code, and I think we're very, very close to doing that. We've also spent some time over the past couple of years looking at the options framework within the JIT, within the compiler. It is a technical debt. If you like technical debt, that's your well, that's where you should be spending all your time. So we've spent some time reworking a lot of that. And we have something that that we've proposed, and it shows good promise with working within OMR. It shows good promise being integrated into downstream projects. It's very configurable, and we want to get that landed relatively recently. We have some work to do in terms of tooling and that, but that I expect to happen in the next several weeks or so. For all of these items, by the way, I'm actually listing either the issue number or the pull request number next to them. So in case you want more information about any of them, you can hopefully look that up. The other thing that we're looking at doing for the compiler is to provide more generic method metadata. So this is information that's associated with each method that gets compiled. It can be used for things like describing, what methods have been inlined into it. It can be used for things for garbage collector maps, that sort of thing. And there has been some interest in this sort of thing for other language environments that want to consume OMR and the need to actually provide this. So we've had this issue open for a while. There's a lot of ideas here. We just need to get some cycles to working on that. And I'm hoping we'll have that over the next get something started on that over the next several months. Another thing that comes up relatively frequently, actually, is floating point performance and floating point capabilities with OMR. What I've been doing for, I guess, a year now, that hasn't actually surfaced anywhere other than any sort of personal stuff that I have, is to actually come up with sort of a floating point plan for the OMR compiler and actually OMR in general. I do want to surface that. It'll talk about things about enhancements that we want to do and how we can even do cleanup of work that's already there. So just as an example of that, there's a lot of code that we have to handle the x87 floating point unit on x86 hardware, which has been sort of long but deprecated, but it's not as easy as one might think to just simply remove. So a floating point strategy, I think, would go away. Well, it'll go a long way to communicating what it is that we want to do on the floating point side. The resolved method hierarchy, conceptual integrity. So this has been it's been an issue for a while now. If you've ever looked at the code, there's a couple of ways that you can look at the resolved method hierarchy. You can either look at it from the top down or you can look at it from the bottom up. Depending on the language environment that's consuming it, your perspective is different. We want to provide a unified way of talking about resolved methods, and well, we need to make progress on that. So it's a particularly sticky issue to get some of the technical details untangled for how resolved methods are being used. What does it mean to be a resolved method? What should be in the hierarchy? What should not be in the hierarchy? That sort of thing. So there's going to be some work happening on that over the next little while. And all the while, we want to continue to make enhancements, language agnostic enhancements to the compiler as well. There's sort of a slow effort to converge a lot of the pieces of the backend. A lot of these divergent properties became very apparent as new backends started to land, like AART64 and RISC-V. You can definitely see duplication in the code between various backends, and it's often very subtle things that are preventing more code sharing from occurring. So the more sharing that we have, the easier it'll be to port this to new architectures if necessary. We still want to continue with some of the refactoring that we're doing as we have time, and also providing greater clarity on what some of the IL opcode semantics should be, and how we test those, and that sort of thing. The garbage collector component has a number of items that are looking to land fairly soon as well. One of which is to look at providing a single build that can do both compressed and native reference builds. So what this basically, so a compressed reference build, if you're not familiar with it, is if you're running, for example, on a 64-bit platform, we can treat pointer sizes for objects in the heap as 32 bits rather than 8 bits, or rather than 64 bits. If the size of your heap can accommodate that. At the moment, though, you have to actually build two separate garbage collectors, two separate builds actually, to handle both a compressed references heap and a native reference heap. So there's work underway right now to unify those to happen in a single build. There's also some work happening on dynamic breadth for scan ordering. So this is essentially some work that when you move an object in the heap. If the compiler can give hints to the garbage collector that there are certain fields in that object that are particularly hot, particularly important, that should stay with the object, the garbage collector will try to move those fields along with the object as well to keep that locality. This requires input from the compiler itself, and I think that there's some discussion happening right now on the best way of doing that communication. So that's an important thing for some performance going forward. The other thing we're looking at is contributing the metronome, the real-time garbage collector from OpenJ9 and surfacing that in OMR. So there's some refactoring work that has to happen in order for that to happen, but that is this proceeding.
So just one more point I wanted to make on this particular slide. So I've been having a couple of conversations with people from the OpenJ9 GC team. So the technical experts like Dimitri, who's actually on the call, I see, and Alex Michik. And I think one of the things that I'd like to do early next year, maybe, as part of this meeting, is invite them to come here and give a bit of an overview on the state of the GC API in OMR that other languages might be looking to use, and talk a little bit about how that API should be evolved going forward to make it easier for other languages to use without, sort of breaking any of the performance requirements that we're currently, helping OpenJ9 with. So I was talking with Dimitri earlier, and I think that's something we could do in the early part of next year. So more to come in this space, I think, is the basic message.
Yeah, cool. There's also some work happening right now in the port and thread components. So there is work right now to provide an optional new locking scheme that will scale a lot better, as the number of threads and the number of cores increase in a particular implementation. Navneet actually gave a talk not that long ago that described the motivation behind this and the architecture behind it in the context of OpenJ9, and I posted a link to that video there if you want to, if you'd like to watch it. It's actually very good. It's about an hour long. This work was motivated by OpenJ9, but the actual implementation of these locks can live in OMR as something that others can consume as well. There's also some work to surface some work that was done in OpenJ9, in the OpenJ9 port library a while ago, where there actually is sort of a generic network socket implementation. We want to make that a little bit more generic in the sense that we don't want to have it J9 specific and then move it up into OMR so that others can use that as well. So that work is ongoing. And similarly, there's a lot of processor detection features that exist in the OpenJ9 port library that really should be living in the OMR layer as well. The advantage of having it there is that certainly the compiler component in OMR and even OpenJ9, I think, comes along and does a lot of the same kind of work. So it'd be nice to clean a lot of that up and just have everybody use one single implementation in the port library for processor detection, and I think things will make a lot more sense then. For the JIT Builder talk, I'll turn that one over to Mark to go through some of these points.
All right, okay. So I guess the JIT Builder API over the last year has been hasn't really been pushed forward a whole lot. There's been some work done in creating a tool so that we can create new language bindings for JIT Builder, and there's actually been a C++ implementation which we're now using, and a C API that's been contributed that I'm hoping to merge soon. And there's also been some other work going on. For the next little while, my focus anyway around the JIT Builder API is actually looking at turning JIT Builder from an API into more of an intermediate representation that should be not language. So the idea here is kind of the next generation JIT Builder, which hopefully doesn't break existing clients, but provides some exciting, hopefully, new features for people who might want to build compilers using JIT Builder. So one of the goals is to make it more extensible and allow clients to be able to add their own kinds of operations and their own kinds of types. I want it to be basically building a representation of the program that you're describing using the API, as opposed to just right now the JIT Builder API is more of a pass-through to the OMR compiler IL. So you make a call into JIT Builder, and that by the time that call has ended, you've generated some OMR compiler IL that's sitting somewhere in an IL generator. But that means that you're basically building everything on the fly. By making the calls into more of a representation, it gives you the ability to walk that representation, introspect it, transform it, and optimize it. So it allows you to build sort of a DSL-like optimization framework on top of JIT Builder. So I'm doing some early prototyping work on this right now. I'm hoping to have something to show by early 2020. Some definition of early, and you know, it's kind of a side project for me, so it's not making huge progress in leaps and bounds, but it's a very interesting one, and I think it will enable some very nice usability improvements for JIT Builder clients. So that's a primary thing that I've been working on. Obviously, there's the LLJB project, which, if you haven't heard of LLJB, it's a project that one of our students created that basically translates LLVM IR into calls to JIT Builder. So it basically turns the OMR compiler into a backend for LLVM IR. And so the goals in this area are basically to round out the IR support. So it currently supports quite a good cross-section of the IR, but not all of it. So we're going to try to round that out some more and finalize its contribution into the OMR project. So it basically becomes another facility available to consumers who want to be able to use the OMR compiler as their code generator. There are still some platform enablement issues with JIT Builder. It doesn't run consistently well across all of our platforms. There's some issues with method trampolines and a few other things that could be improved. So we're hoping to round that out. I don't know that we'll complete that in the next few months, but it's certainly an ongoing area of improvement. And Daryl's actually been making a lot of improvements in this space, getting us closer there. And then obviously the work that Philip did on getting JIT Builder working on the ZOS platform is a major advancement there that we managed to get through this year. Finally, there are a bunch of areas in the JIT Builder associated with the JIT Builder project that I don't know that there's any sort of active work going on, but they're areas that we're always interested in. And if there are people interested in working on these, I think we could find people to help with mentoring, coaching, etc. So there is some interesting interpreter builder work that people like Robert and Charlie have worked on, you know, in combination with the ability to also generate a JIT automatically for an interpreter from with essentially a virtual machine specification. So that's kind of a direction that I'm hoping to move things, you know, forwards on, but I don't think anyone's actively working on it right now. JIT Builder currently lacks the GC interfacing ability right now, and I think that's actually true of the OMR compiler. So that would also be an area that would be very useful for us to move forward on. Java language bindings is something that we've been interested in rounding out. There actually, I shouldn't say there's no work going on in language bindings. There is a project going on that's looking at Python language bindings for JIT Builder. That's actually yielding some quite interesting results actually. And hopefully that will be landing in the next few months. And then finally, just underlying refactoring work to help with making JIT Builder work more effectively. So I'll stop there.
Okay. All right. So testing. So there's a fair bit of activity planned on the testing front. I don't want to go into any detail at all on these actually, because next week at the next week Architectures meeting, Shelley Lambert will be here to basically go through all of these in much more detail. A lot of these are sort of her thoughts and apply some of the experience that she has from the OpenJ9 project to OMR. But just briefly, you know, we need to provide more documentation for the tests that are there, and to make sure that the coverage, we haven't looked at the coverage of the tests in quite some time, and some of them we haven't even looked at all. So we need to make sure that the tests are doing what we expect them to do, and that we have confidence in what they're testing. We'd like to get some sort of performance testing framework in place for OMR. I know Shelley's got some ideas around how this can apply to the garbage collector, but at some point we should probably expand this out to include compiler testing as well. There are some ideas around testing OMR in the context of other downstream projects. So this isn't just an OpenJ9 thing, but it could also be other language environments that are consuming OMR. How do we ensure that we don't break anything, that OMR doesn't break anything in those downstream projects with changes that are made? And there are some examples in other projects where downstream projects testing can be accomplished within the upstream project. So Shelley has some ideas around that she'll be talking about next week. There is some work that we wanted to do on the FE test directory itself, and just changing the shape of it. I think it's kind of grew up over time in interesting ways, and different things have been added to it. But I think that there's an opportunity to sort of straighten some of that out and make it a little bit more intuitive. And Trill itself, the framework for testing the compiler, there are a number of improvements that we want to make there. Philip recently asked about doing some work on performance and making sure that methods, we don't continually compile the same methods over and over and over again, and have more of an opportunity of sharing some of those methods to improve compile time. Not just, well, improving compile time, which will eventually improve your build time. That's the end goal. And then continuing along the Trill roadmap that we've established more than a year ago, we talked about this at one of the architecture meetings. There's a large number of things that we want to do there, and we want to basically carry forward on some of those as there are people that are willing to do those sorts of things. So anyway, more on testing next week. There's a number of projects, academic projects, that are using OMR for various research purposes. There's a team at IBM here that is in contact with a number of these research groups, and are actually helping them along with some of that research. And for those particular interactions, I've just listed a few of the ones here that are likely to show code that'll arrive in the code base in the next few months or so. The first are a couple of projects from the University of Alberta. The first is a benefit-driven inlining. So Eric Ochoa talked about this at an earlier architecture meeting this year. Slides and recording are there if you're interested in that. But it's a promising new way of doing inlining that we'd like to get integrated into OMR. So some PRs have landed already, and we expect more to come over the next few weeks. There's also a group that's looking at the way that some of the classes have been architected in the OMR compiler, and trying to decide what the best way is of providing the extension points that we want. Those that are familiar with the code know that we use something that we've been calling extensible classes. There's a lot of good reasons for those, but there's a lot of perhaps negative aspects of using extensible classes. So this is actually a research study to look at all the requirements that the OMR project has, all the constraints that the OMR project has, and sort of coming up with a recommendation on, for this kind of a project, what is the best thing to do. So there were some earlier results that were presented a few months ago. I've linked them here, but this is certainly an ongoing research project, and we're looking forward to getting some input from that study and helping to influence the architecture here. The University of New Brunswick also has a number of projects that are using OMR. The first is sort of a generalized AOT infrastructure in OMR, so ahead of time compilation. They're working on surfacing a lot of the work that was done in OpenJ9 for ahead of time technology and making it language agnostic, and then surfacing it in OMR. So there's a couple of designs and issues that are that I've linked to here. So some of that code is starting to appear, and it's under review right now. Same thing with a shared class cache infrastructure in OMR. So moving that up from OpenJ9. So that work is underway. As Mark mentioned earlier, there are projects to look at using JIT Builder as well for doing Python acceleration through language bindings for JIT Builder. Some of that work may see the light of day in the code by sometime in 2020. And similarly, there's some work undergoing right now to look at integrating the garbage collector in OMR into PyPy and investigating the performance benefits of that. From an infrastructure point of view, there's a few things that are going on. So the first is to kind of round out some of our CI builds and testing that we do on before merging pull requests. So right now on AR64, we are only doing cross-compiled builds. We don't actually have any testing that's running there. We want to do something about that, either actually getting native hardware or running some sort of an emulator to at least run some of the tests if we can't get hardware. And similarly, as the RISC-V backend lands, we want to make sure that there's a CI pipeline in place for that as well. So so we need to institute that as well. Not all of the builds that we have right now are using CMake. There are still some that are based on AutoTools, and we want to deprecate AutoTools in favor of CMake. So there are about 3 or 4 builds that still need some work done there. I think the ARM builds and the linter jobs that need to be changed. So that's just work that needs to get done. And then we've been looking at doing source code formatting and providing some infrastructure as part of the check-in process for doing that. So we've had a discussion on that last week in the architecture meeting, and I think that there will be some. There's a good set of issues that Philip has created that's sort of tracking the work that's going on there. So if you're interested in that, by all means, please read through those issues. There's a lot of good stuff there, and the discussion is very active. And another thing that we could possibly do as well is to enable the automatic copyright verification on commit. That's a fairly common problem that gets, and especially now as we're going to be rolling over the year, there's going to be a lot of missed copyrights on some of the PRs that people are making. That enabling the automatic copyright verification is something we want to look into. And then the final thing that I want to mention here is just some work on the website and documentation. So we do have a new website, as I mentioned before. It was primarily there to host blogs that were written. It's a WordPress site, so it did host a lot of blogs on various technical topics. We want to continue that pattern and get more blogs written there. We also want to summarize a lot of the academic collaborations that we're doing on that site, talk about the projects themselves, just so that people are aware of that. There has been some interest in finding out what projects we're doing with OMR and what academics are doing with it. And I think that it's important to get that information out there, so we're going to do that. And similarly, downstream projects that are consuming OMR. So not just OpenJ9, but we've got we have projects with WebAssembly. We've got projects with Lua. We've got the RISC-V work with SOM, right? So there's all these different projects that we want to at least mention here, so that people can find them and learn from them. And lastly is a Wikipedia entry for Eclipse OMR. We are remiss in that we don't have one, and we need to write up some content there and get that posted so that we get some hits in Google when you look for Eclipse OMR. So okay, so that is the sort of the whirlwind tour of what it is that we are planning on doing over the next few months. Certainly want to pause it now and open up for any discussion that people might have on this, or any questions, concerns, other thoughts, that sort of thing. Volunteer for help, that kind of thing, which is what we really need. And if not, we can go right on to Jack if he's available. I think he's online.
I'll just message Julian Dolby, who also wanted to join.
Sure. All right. Well, I mean, anytime anybody wants to raise any issues or concerns with the work that's going on, or have any ideas about areas you want to go, by all means, open an issue or pose a question on Slack, something like that. We're always willing to take it. Okay. All right. So I think we will turn it over to Jack. Okay. Jack, Julian Dolby wants to join, so maybe just give another minute or two for him to join.
Yeah, he's showing offline when I was trying to get hold of him on Slack, so we may just have to make a start and Julian can join in at the end. Otherwise, I have discussed with Julian. I can certainly touch on some of the points he wanted to raise if he isn't able to make it in time. Okay.
Okay. We can see your presentation, Jack.
Okay. Okay.
Take it away then.
Can you hear me?
Yes, we can hear you, Jack. Thank you.
Okay, cool. So today I'm going to talk about the OMR and voila linkage for short. Before I go to explain what it is, just let me give some background information of this project. So my name is Jack. I am currently a third-year computer science student at the University of Alberta. I have the chance to work on OMR, the CanOps program, and it is done as part of a course project. LJB and OpenJ9 will generate OMR intermediate language in order to do all this work. And I get mentored and advised by Andrew and Julian through this semester, so big thanks for their time. Okay, so what is voila? Briefly speaking, voila is an analysis tool for Java bytecode and other languages such as JavaScript and Python. So why do we want to connect OMR with voila? Because we enable OMR to have the program analysis ability provided by voila. So the challenge is voila cannot consume OMR intermediate language directly because it was not designed to do so. However, voila can take Java bytecode as input to perform the analysis. Also, voila provides a Java bytecode class abstraction called StrikeBT. For example, the StrikeBT constant I0 is equivalent to icon0 opcode in the Java bytecode. They have very similar ideas. Local store I0 is equivalent to iStore0, and so on and so forth. So we come up with translate OMR intermediate language into StrikeBT instructions. And then we StrikeBT instruction into the voila to perform the program analysis. Here, a very simple example. Basically, those 3 lines of code are doing an add operation of 2 variables A and B. The picture on the left is a OMR intermediate language tree, which you should be very familiar with. And the one on the right is StrikeBT instruction. They are doing the same thing, adding 2 values. And the next picture is the overview of the architecture of OWL. The OMR compilation option is taken as an initial input, and that is all we need to perform the translation. The OMR tree will be passed through the OWL mapper to be translated into a sequence of translation objects. So what is a translation object? A translation object basically contains all the necessary data to make a strike BT instruction. For example, to make a strike BT constant instruction, we need to know the type, the actual value of this instruction. A local store translation object contains the type and the local variable table slot index. The strike BT instruction constructor takes this sequence of translation object and makes them into strike BT instructions. And then we pass those instructions to the voila verifier to verify if the instruction generates valid or not. If the instruction passed the verification, finally we can let those instructions enter the voila to do the analysis. But written in Java and OMR is written in C and C++, so we have to use the Java native interface to invoke the services provided by voila. Such an approach will cause trouble if L is integrated in the OpenJ9. Think about creating a Java virtual machine inside a Java virtual machine, so it just simply does not work. So we improve the flow of L. The previous steps should be the same. Do the translation, produce translation objects, but the next step, we need to check if JVM created by the Java native interface can be started. So in OpenJ9, it cannot be started. So we pass the translation object to a serializer. The serializer will serialize the translation object to a file on disk. After OpenJ9 finishes running, we can take this serialization file, enter it into the deserializer. The same translation object should appear again, and then we do the following steps. The idea of the translation is quite simple. Walk the tree in depth first search and evaluate each tree node, and then we map into the corresponding strike BT instruction. Images on the right show the exact same example I gave in the previous slide. Basically, it performs the add operation. So we start from the first tree top, find its deepest child. It is constant 1 in this case. Evaluate it, map it into the strike BT constant 1. Then we return back to its parent, which is a store. It will be mapped to the local store 0. The 0 is the slot index of the local variable table. And then we go to the next tree, same thing, so on and so forth. Here are some more details about the translation. The OWL mapper does the job is owlmapper.bp. If you want to look at the source code, the mapper itself contains a local table. It records the slot index of the method parameter and local variables. So how the translation is done, the first step is to store the method parameters into local variable table. Those parameters can be get from the compilation objects. Then walk the IL tree to the mapping, as I mentioned in the last slide. After we finish the mapping, to adjust the offset and the target of the branch instruction, such as go to and conditional. Because in OMR, branch target is pointing to basic block, but in strike BT, the target is pointing to the instruction offset. There are some considerations when we evaluate the node and map it into the corresponding strike BT instruction. We also should be careful about the side effect of the instruction may have on the operand stack. So let's at the following example. We create a new object without assigning it to any variable. The reference of this object should be discarded from the operand stack. So the translated instruction should be new, and duplicate reference on the operand stack invokes the constructor, and then pop the reference from the operand stack. OMR does not have pop instruction because it is a tree-based IL, but we can decide whether the pop should be generated by its reference count. The reference count indicates if this node will be referred later or it will be referred anymore. Next, I am going to introduce implicit load and store. So why call them implicit? Because they are created by the translator instead of being mapped from the OMR IL. What's the point of creating them? Let's look at this example. So in this case, method foo.get1 with return value of type integer is invoked, and this value is stored in a variable. When traversing the IL tree, at the time the I core I is evaluated, we don't know which nodes will use the value of the core indirect later, if only traversing the IL tree in a single pass. It's possible that an I core I will be referred immediately by the following node. It is also possible that it will be referred very far away. All we know at the time when we evaluate I core I is that this node will be referred later because its reference count is greater than 1. So for such nodes, we create an implicit store for it, store it as if it is a local variable, and load it back whenever we visit this node again. So we evaluate the first time we evaluate I core, we know this node will be referred again. So we create an implicit store, store it to the local variable table. And the next time we refer to the I core I, we know it is inside the local variable table. So we load the value from the local variable table. And this I store is actually, it is an explicit store because it is in the OMR IL. So we store the value into the local variable table at slot number 4. Although in this example, the implicit load and store is redundant, but it guarantees the overall correctness. So here is the list of already translated instructions, including basic arithmetic instruction, control flow instruction, object-related, and array-related instructions. Here are some possible use cases of OWL in the future. I believe Andrew has some idea about this. So Andrew, can you talk about those use cases?
Sure. So just to provide a little bit more background, voila as a static analysis tool has been quite popular for program analysis research from a number of different sources. So there's sort of two very large frameworks that are used for static program analysis of object-oriented programs. So there's the Soot-based frameworks that are primarily focused on Java. Voila was written as an alternative, initially, analysis framework for Java, but has subsequently grown front ends for Python, for JavaScript, for Swift, and has been used as a vehicle for static program analysis research. So one of the motivations initially in looking at this hookup, as you saw, there are research collaborations where people at University of Alberta are looking at OMR. There are a group of people at the University of Alberta who have a background in static program analysis. Kareem Ali, who's a assistant professor there, who's worked on the Inliner project, also does a significant amount of static program analysis work. And he was interested in trying to be able to use OMR as part of a vehicle for some of his research. His other research is being done using Voila, so being able to bring the tools and techniques that he has available in Voila to all of the languages that might use OMR, as well as being able to look at things that are unique to OMR, was interesting. So going forward, the advantage of having a connection to the voila analyzer, there's a number of kind of tools or analyses or utilities that one could easily see building based out of a static analysis framework like voila that are kind of beyond the scope of what a JIT compiler or what's currently resident in OMR. It's a tool that would allow people who are interested in language research to build upon the OMR ecosystem to be able to further their research goals. Further, the results of these kinds of static analysis frameworks could also be used to help inform compilation. So with the notion of AOT and the notion of a shared class cache eventually being contributed to OMR, the fact that you could run a program or analyze a program ahead of time statically to produce results, and you could use those results later is certainly another aspect of what you could do with this hookup. And this was a first attempt at trying to connect a static analysis framework to the OMR IL. It's not something that we tried doing before, and especially with voila being a Java-hosted analysis framework, which is the same as Soot, both of them running the JVM. There's obviously some non-trivial engineering that Jack has had to do here to make the two parts sort of cooperate. So there's been interest in it from both sides of that, and Jack has done, I think, a very good job considering this was like a semester-long, one-class kind of project to get this up and going. And that he's managed to get quite a lot of basic functionality working. In fact, they've got some analysis results and things that can be shown. So I think that it's an interesting project from the point of view of having a broader set of tools. And it also means the JIT builder and things like that, if you choose to use OMR components, if you choose to consume the OMR compiler infrastructure, you also get access to static analysis tools with no additional overhead. The tool will just work. I would point out that while Jack did describe the Shrike BT instruction set as being a Java-like bytecode instruction set, and it certainly is, there are other front ends in voila that target the Shrike BT instruction set. So their translator for the .NET Common Language Runtime opcodes go to Shrike BT. There are other, I think the Python goes through that pathway as well. So
Andrew?
it's not yes, Julian.
Sorry, I thought I had heard 3. Sorry, and then I got distracted.
Okay. So
Anyway. I do have the ability to run the example of the call graph builder if you would like.
Sure, we'll come to that in just a sec. So I was just motivating why the OMR project is interested in this, and I think that one of the main motivations I had for asking for Jack to be given the opportunity to present here is that there's a significant amount of work that's being done. There's obviously more that needs to be done, but it's going to outlive the amount of time that he has to work on this particular project. He's gotten it off the ground, and I would like to ask the community to consider where we might be able to provide a home for this in the longer term so that people who are interested in working on it as part of research or tools or things like that would be able to benefit from what he's done.
Yeah, one place, if you want to consider it as a home, it might not be technically the easiest would be the voila site. That might be awkward to arrange since it's mostly bound up with with OMR.
Yeah. So anyway, we can have that discussion in a moment. Jack, I know that you managed to get the tool running. Was there anything that you wanted to show, or was Julian going to do the demo for like what was currently working?
Yeah, so only one slide left. It's just mentioned the GitHub repo that's linked to code. So the first one is called OWL. So it just contains some pre-generalized serialization files of some test cases. So you can run analysis with those test cases. But if you want to generate some code with it's nest repo, so it contains all the source code of OWL. So I think that's it. So I think next thing is that Julian to show the demo of the work.
Sure. Okay. Well, thank you for the talk, Jack. And I think, Julian, if you want to just showcase what you've gotten working over the course of the term, that would be helpful just for 5 minutes for people to see what's working, and we can have a discussion about the future of it after that.
Do I have to share the entire screen? Share. All right, it looks like I have to share my entire screen.
While we're waiting, what's the overlap between OMR IL and whatever I forget what the name was, Shrike or
The Shrike BT instruction set?
I mean, there are some more complex OMR IL opcodes,
Yes.
for example, a write barrier or.
Yeah. So when it comes to the mapping is not one-to-one. There are some OMR bytecodes or opcodes that do not have an equivalent in voila, in the voila Shrike BT instruction set. So the check opcodes are certainly a primary example of that. The Shrike BT instruction set is like Java in that array accesses are bound checked, dereferences are null checked. So the check opcodes, by and large, do not result in instructions that are generated in the Shrike BT instruction set. Now, some of the more complex opcodes in OMR, such as an array copy or an array translate, would have to explode into a number of bytecodes for Shrike BT. Now, write barriers, and I won't ask what just blew up. But the write barriers and read barriers are interesting in that we use a different opcode in OMR because we're capturing low-level implementation details or details related to how the operation interacts with the runtime. But from the perspective of program analysis, a write barrier is actually no different than a store indirect. So for those ones, they actually map to the same translation in the Shrike BT instruction set because voila does not care about the particular details of what gets notified. It's concerned about overall program semantics, not the low-level execution semantics within the runtime. Okay. If you particularly wanted to model it for some reason, you could explode it. But I mean, for the purposes of analyzing the original user program, it's not necessary. Okay, we can see Julian's screen now. Hooray!
Okay, if you guys see the screen, so Jack, what Jack told you about was how the system can talk to the OMR compiler, can extract IR, and then can generate these arrays of Shrike instructions, and either can pass them directly to voila, and so to do analysis kind of online, and also you can serialize it, which for at least from the point of view of developing stuff is easier. So Jack created a bunch of serialized pieces of IR, and so we can just take a look at one of them you may have seen. If we just look at examples, add.java, it's this little program here. Doesn't really do much. But then what we can do, he ran that program through OMR, collected all of the IR, and so that allows us to run this program. So we basically take the log file, we stick it into voila. So the first thing you see at the top here is the voila IR. So there's Shrike. The Shrike IR that Jack generates is a more or less completely literal interpretation of Java bytecode. And what we do with that is we turn that into an IR that's a little more amenable to analysis. So you can see, if you look at the instructions, there are these that would have 2 adds, which in bytecode would have local loads and stores and things like that. And what we've done here is we've turned it into a bunch of things with SSA value numbers. So there's 2, 3, 4, 5, 6, and so on. So what that's showing is that the IR that the Shrike BT IR that Jack builds is, really indistinguishable from the kinds of IR, the bytecode that we read from class files or we generate from source code. And so Voila can turn that into the SSA-based IR that we use for program analysis. And just as a simple example of what you can do with that, the next thing you see below here is a call graph. So we start with this fake root method, which is just the root of the call graph. Then it has a fake, it had a special node for all of the class initializers, and they call various object and class initializers. And then there are the class initializers. There are some native things in the Java library. Because what we're building here is a call graph in which this method that Jack created is treated as the main method. So you see a call from a main. You see a call from main to the operation, right? There's invoke static, it calls the various initializers, then it calls the operation. The operation just adds numbers and doesn't really call anybody. So the call graph doesn't have much in it, but the point there is to illustrate that the IR that Jack built is already real enough that it works indistinguishably from other IR in Voila call graphs. It can be mixed and matched freely with other IR. The library there is read from bytecode. So if we had a world in which OMR had generated a bunch of IR and we could read in anything that wasn't compiled, we could read in this bytecode and we could put it all together into a call graph. And that's stuff that already works now. So that's pretty much all I wanted to show you, just to illustrate that this IR that Jack built is it's a real Shrike IR. It's completely it has everything that Voila needs.
Okay, thank you, Julian. Thank you both for the presentation and for coming to the meeting. So I guess I'll turn the chair back over to Daryl since he normally runs this.
I would just like, I'd also like to comment that those of us who work on Voila are definitely excited by this. I mean, there have been, right from the beginning when at research, we were looking at the things like the JIKES research virtual machine, we were interested in doing research in optimization in the context of a virtual machine. And this might be another exciting way to think about doing it.
Okay, thank you.
Right. Yeah, thanks, Jack and Julian. I guess the question would be, you were thinking about what to do with the code. I mean, I guess what are the next steps here? Were you thinking about contributing this to OMR? Is there a pull request or something that we could look at the code? Or
well, I think the reason for having the talk was to discuss if OMR would be interested in hosting the code so that a pull request could be opened. Obviously, building the OWL code has, like the code that actually does the inflation to Shrike BT instructions has dependencies on a JVM to actually build. I'm not an expert on the OMR build system, so I wasn't quite sure how that would fit in or how the community would feel about having code that had a dependency like that. There was a consideration, should it go with the Voila project, but building it there is even harder, I think, because the OWL mapper is actually an optimization path that basically just runs to walk the trees during a compilation to generate the Shrike BT instruction set. So to my mind, the more logical place to put it would probably be something related to OMR. Now, I don't know if people feel that it should go in the main repo, if there's somewhere else we should host it. I just would hate for all of this great work to be lost and just sort of sitting off in a side repo that nobody ever looks at, I think is my main concern.
We were talking at one point about having an OMR GitHub organization that would let us put repositories like this as kind of on the side of the main OMR repo. Did that go anywhere, or?
No.
I mean,
short answer that.
It would involve going through some of the same hoops that, I mean, OpenJ9 went through some hoops to try to look at what it would take to become an organization for different reasons.
Yep.
But could it potentially become, this code become repositories in the same organization? Isn't that easier?
Yeah, but so right now, OMR is a repository in an organization called Eclipse, under which all the Eclipse or organization projects, foundation projects that are on GitHub reside. So right now, we don't have any other way of, like there's only kind of the two levels of things you can do. You can either be an org or you can be a repo. Or right now, we're a repo. So it's possible to petition the Eclipse project to become our own organization, which has some other implications associated with it too, I believe. We could look into it. There's no reason why we can't look into it.
Because
I mean, there are other examples of these things too.
Yeah.
Like Base9 would be another.
and that's my thinking. Is
Some of
we
the
already
other-
have several things that would fall in the same boat. That,
Yeah, like we could pull even Lua Vermella and the Rosie pattern JIT and all that, all the basic porting projects that we've created. Right, it would give them a place to live that's kind of associated with OMR, for better or worse.
I guess, and this is, as Andrew said, and I think I agree, it's not entirely ideal, but on one GitHub organization that we do already have is Voila.
Right. So, can you talk a little bit about how what are the big pieces in what it is Jack's done so far? So obviously there's the optimization path that you mentioned.
Right.
What are the other pieces?
Okay, so there's a piece that is the optimization path and the associated stuff. There is then the serializer. So he has a serializer class that's able to write the binary file, which is a representation of his translation objects that he produces in the mapper. There is the deserializer dual of that. There is a library of JNI utility functions that simplify the writing of the hookup to the Shrike API, which is a set of Java methods. There's the piece of code that actually walks the translation objects and calls the JNI dual to create them. And there's a piece of shim code that gets from there basically to pass a Java array of Shrike VT instructions into an endpoint inside Voila, which fires off this analysis, right? So that may need to be retargetable for different use cases, but essentially, module JNI code, opt path, custom serialization, deserialization, and associated GUMP are the main pieces right now.
And are there any, how many of those pieces have dependencies on things outside of OMR? Like is the serializer, deserializer stuff, is that
That's self-contained. That's self-contained.
All right.
The main dependency is the JNI dependency and the Voila dependency for the inflation and the calling.
And I guess also even the creation of the instructions. So Jack, sometimes even in the compiler pass, at least in theory, there's a way to call Voila straight from there, isn't there?
Sorry, my network.
So I thought you have the serialization route, which is what we've been using, you and I. But there's also, you can also call Voila, I think, directly from OMR, can't you? Or does that not work at all?
So try to create a JVM.
Yeah, I think
right. So whether you go, so he can create the translation objects, and it's whether you're going to serialize it or call directly into Voila. That's the question, right? Are you going to do the Shrike inflation in compilation, or are you going to just serialize
what needs to be inflated and inflate it out of process later is the choice.
Actually, there are two options. So in LLJB, so it can be called directly because we can create the JNI, but in OpenJNI, you have to serialize
Right.
translation object to file because the JNI cannot be started at the time when the OpenJNI is running. So there are two options. It depends on which one you use. Yeah.
That's a tough one. Yeah, there are pieces that obviously sound like they could fit reasonably in OMR, like the optimization path, for example, and that's probably something that you would want to live in OMR, just so that everyone would have access to it.
Yep.
The other bits, and maybe the serialization, deserialization bit, have a place in OMR. Then it starts getting dicier. Right? Maybe another repo is the right place for that stuff to kind of reside. So if you're going to build a static analysis path that builds on this stuff, here's the stuff you need to do it with.
Yeah.
At that point, having that repo be in an OMR org makes a lot of sense, I think, because there's an association, but it's not a tight.
Yeah.
And if it did with OMR, I guess the one question in my mind is when would we run testing on it? Like CI testing would actually need to assemble all the different pieces and run testing on it, or
so you just plug the Travis CI build right in the new repo.
in a new repo.
Yeah,
you do that. I mean, but if it actually lived in OMR, how would it be tested?
I don't know that it necessarily warrants testing on every single PR. I think it needs to be tested regularly as part of the family of things that we should test regularly when we're doing architectural changes that might break downstream consumers. This certainly is another one that comes into that category.
Just curious, where does it run in the strategy?
Very early. So generally, in LLJB, it happens basically after the first sort of passive sort of simplification and dead trees, just to simplify the IL a little bit, but before anything else. In OpenJ9, it's being scheduled basically in the same place. So after IL Gen Ops and like the first passive simplification, it's before the inlining, just because the translator is not capable of dealing with that yet. There's no reason it couldn't, but it hasn't yet.
Nothing's going to get decided on this call, but I mean, I think I'm open to having parts of it be in OMR. It doesn't sound like all of it maybe should be in OMR, but we can discuss the particulars in an issue.
Yeah, create an issue for that.
Yeah. Okay. So maybe the concrete thing to do is for Jack to create an issue on the OMR GitHub repo, offering to contribute OWL to OMR, and then the committers can have a discussion on that issue about which bits or where it will land, and we'll try to arrive at a conclusion expeditiously, just given that Jack's semester is finishing.
Right. Okay.
We didn't come earlier just because he was finishing getting the parts together. It's been a fair amount of work in one semester.
It's very impressive for a one semester, one class effort. That's very cool.
I guess one thing I wonder that maybe you guys have some perspective on is to what extent is thinking about sort of global kinds of optimization something that the OMR project is interested in? Would you imagine a world where you might actually want to use an analysis like this to think about, doing inlining or something like that?
I wouldn't say we're not interested. I would say it's probably not the direction that we would naturally flow in, just because we're naturally expecting to be used in a JIT kind of scenario. But having said that, there are static compilation scenarios and connected static dynamic compilation scenarios where I think, the ability to do deeper analyses makes a lot of sense.
Yeah, like J9 had all those things like those big precompiled archives and stuff like that.
Yeah.
So there are certainly areas like providing hints to the optimization where I think static analyses could play a big role.
Yep.
We have another project actually that's going on, a research project which aims to guide better escape analysis decisions. And part of that could very well be directives on what to inline to bring the right sort of APIs inlined into their caller such that maximum scope is exposed. So yeah, I think the hints area is one that we're quite interested in, I would say.
I think it's a space to be explored more. Like static compilation and dynamic compilation have always been relatively separate things, and with the advent of AOT and shared class cache and things which are going to arrive in OMR, it creates the opportunity for these kinds of analyses to be consumed for the first time. And I think that rather than being able to say it's definitely something that the community is going to do, I think it's a great opportunity for some awesome research and some awesome exploration on how these things can be brought together to do awesome things going forward.
Yeah, so I don't want my leading statement to be seen as pessimistic. It's not something we're not interested in. A lot of negatives, but my point was to actually be welcoming with that. Like but it isn't something that traditionally we would invest in. But that's not to say that it wouldn't be valuable.
Yeah. Okay. So Jack will create the issue then, and we'll go from there.
Okay. And we have an issue already for moving the OMR into an organization in GitHub. So, in the spirit of and the aspiration of backlog reduction,
there's a small, simple one to start with.
We're full of aspirations.
Okay. All right. Thanks, Jack and Julian. Any more discussion before we close the call? No. Okay. Thanks everyone for joining this week, and we'll adjourn the meeting now. Thanks.
Thank you.
Bye.
Thank you.